An idea born in unsettled times.
We are going forward. America, the United States, is first in space.
Becomes a feat of engineering excellence. The most complex machine ever built to bring humans to and from space.
Zero and liftoff of Endeavour.
And eventually construct the next stop on the road to space exploration.
Request to take the radio call sign Alpha.
As 30 years of flight draw to a close, its legacy is one of unsurpassed achievement. NASA Space Shuttle. Space Shuttle Endeavour is rolling out to Launch Pad 39A at NASA's Kennedy Space Center in Florida. In 24 missions, flown over 20 years, Endeavour has logged more than 103 million miles in space. The last of NASA's shuttles to be built, Endeavour prepares for her final flight, STS-134. Endeavour's 6 astronauts have trained for this mission for years. Well before any shuttle reaches the launch pad, however, a staggering amount of work is required. The parts, plans, and people necessary to make each launch span the entire nation.
You've got all these people, all these folks that are in their 20s, some of them in their 30s, and they are, no kidding, in charge of some part of the space shuttle, some part of the space station, or some part of the plan. And every one of those people absolutely believes that they are the one that makes the difference on getting those astronauts back down to the ground alive.
At NASA's Mission Assembly Facility in New Orleans, production begins on the shuttle's external fuel tank. The last of 136 produced here since 1973. Around the same time, in Clearfield, Utah, technicians at ATK Launch Systems start work on the shuttle system's solid rocket motors, or boosters.
Fire.
Unlike the orange external tank that is used only once, the boosters detach themselves and parachute into the Atlantic Ocean. They are then retrieved, refurbished, and reused on later missions. The shuttle mission's crew is assigned. Right up until launch, a shuttle crew will train in a variety of critical regimens, some basic, others specific to their mission. Simulators, safety and contingency, science experiments, and underwater in the world's largest indoor pool. One month later, the ET is mated to the solid rocket boosters to form the backbone of the stack. Now, all that's missing is the spacecraft itself. Looking now much like it will at liftoff, the space shuttle is carried to the launch pad atop the 6 million pound crawler transporter at a blazing pace of less than a mile an hour. Not exactly warp speed.
At our peak, carrying full load, we get right around 38 feet per gallon.
Not too bad for an original 1965 hybrid vehicle with low miles. The 3.4 mile journey takes up to 6 hours. Now on the launch pad, the orbiter is ready to take on its main payload. Testing assures that the multi-ton cargo is secured and safely stowed in the payload bay before the technicians certify the orbiter is ready for launch. Flying T-38 aircraft from Ellington Field in Houston, the crew members arrive at Kennedy's shuttle landing facility.
This is the NTD conducting the launch status check. All stations verify ready to resume count and go for launch. OTC, OTC go. TBC, TBC go. ATC.
After nearly 3 years, hundreds of thousands of hours logged by engineers, technicians, scientists, seamstresses, electricians, and other program workers across the globe,
We have main engine start. 2, 1. Booster ignition.
The shuttle makes its way skyward. At liftoff, 6.6 million pounds of thrust begin hurtling the vehicle and crew at speeds that'll reach 17,500 miles per hour. The shuttle is like no other machine ever built. For its launch to succeed, more than 1 million parts must move together perfectly. How this engineering marvel came to be is an amazing story that begins in the early 1970s. A new mission is sought for NASA to send humans into space, but Mars, for many the next logical step on the path of exploration, is dismissed as too costly, a destination for a country preoccupied with events back on Earth. Instead, on January 5th, 1972, another destination is selected. Low Earth orbit.
President Nixon really liked the idea and told the NASA administrator, go do it. And the NASA administrator got a call from OMB the next morning, someone there, and said, hey, what the president really meant to say was, you're going to get this much money, and so do as best you can with the space transportation system. And our choice, logically, was you have to have a vehicle first, and so that was the birth of the Space Shuttle as the first in the 3-part space transportation system.
Many designs were considered. Often, they combined the best features of different concepts. One was the use of a lifting body, an aircraft with no conventional wings. Only its fuselage would keep the aircraft airborne and guide it safely back to Earth.
At that time, they were looking at having jet engines on the shuttle for landing and for transporting it across the country.
They were known as the flying bathtubs. For the first test, the M2F1 was towed behind a car, a souped-up Pontiac. Whitey Whitesides drove that Pontiac across the lake bed at about 120 miles per hour, dragging this flying bathtub behind it.
As well as groundbreaking, their tests could also prove ground shaking. September 1976, more than 4.5 years after President Nixon signed off on its development, America's new spacecraft, Constitution, gets its first close-up before the cameras. The orbiter itself was well received by the public, but impassioned fans of a particular long-canceled television series called Star Trek wanted it called something else. They staged a successful write-in campaign, and the orbiter was renamed for the Starship featured on the show. Thus, NASA's new shuttle would be the Enterprise, boldly going as no spacecraft had ever gone before. Whatever its name, this bird still needed to prove it could fly. In an age before computer simulations, balsa wood models and wind tunnel testing was the only means to test the airliner-sized glider.
We put together a very aggressive flight test profile that consisted of data points continuously all the way down. There was not a matter of 10 seconds went by without another either pitch doublet or a rudder kick or an angle of attack sweep. The things that really turn on a test pilot to fly them as accurately as possible.
August 12, 1977. On a crystal clear California morning, high above the Mojave Desert, 2 NASA test pilots ready for Enterprise's first flight. The plan was for Fred Hayes, Jr. and Gordon Fullerton to lift the orbiter off a modified 747, then land on a dry lake bed 15,000 feet below. Columbia, NASA's first orbiter, is fittingly named after the first American vessel to circumnavigate the globe. While the new class of NASA astronauts trained for subsequent shuttle flights, Columbia was undergoing preparations for the program's maiden voyage, STS-1. Veteran astronaut John Young, one of the 12 men to set foot on the moon, is in command. His pilot is first-time flyer Bob Crippen. Together they would travel over 1 million miles and circle the Earth 36 times.
John used to say, Crip, hey, they're getting ready to light off 7 million pounds of thrust under you, and you're a little bit excited. You don't know what's going on. And both John and I knew what was going on.
Launched like a rocket 2 days earlier, Columbia lands as a glider on the dry lake bed of Edwards Air Force Base in California.
We do a big turnaround to land on the lake bed for that first flight. And I remember when John went into a bank, a big left bank, I looked down at the lake bed, and there's thousands of people out there. And I said, John, look at all those folks, which had come out to see us land.
Anyone who was associated with the program or there just to see the shuttle return, I think felt a lot of pride in our country and our space program. And so those emotions were, finally released, and you said, wow, the flight was done safely, they're back home. The shuttle really does work. It's a great program. It's got a great future ahead of it.
Liftoff of the Challenger of Columbia. Discovery, and the shuttle has cleared landing.
For more than 30 years, the fleet and thousands of Americans dedicated to its safety and success have toiled in exhilarating triumph, heartbreaking tragedy, and most often, quiet obscurity. Their contributions have extended beyond the bounds of space. Among others, shuttle-derived technologies have been used in developing an artificial heart and limbs, three-dimensional biotechnology, a light for treating tumors in children, and improving crime prevention and wildfire detection. From crawler driver to payload specialist, from scuba diver to pilot, from scientist to engineer, they and many like them throughout the nation share a commitment to sending humankind safely into space. That dedication, as much as any other acclaim, will be the legacy of America's space shuttle.
I think will be remembered in thousands of years, as perhaps the most incredible technological feat of humans of our time.
As is the order of life, an ending for the space shuttle becomes a beginning for a space-bound successor. Soon, America will again send astronauts into orbit and beyond to do what NASA does best: explore.